This final episode in the econometric sequence ties together the main forecasting ideas in time series analysis. The focus is on autocorrelation, autoregressions, forecast errors, and the big warning sign that sits over all of this, non-stationarity. Start with autocorrelation. This is the correlation of a series with its own lagged values. If GDP growth this quarter tends to be related to GDP growth last quarter, that is autocorrelation. It is a feature of the time series itself, not just of a regression residual. And it is the reason autoregressive models make sense in the first place. An autoregression is exactly what it sounds like, a regression of y on its own past values. In an AR1 model, current y depends on y from one period ago. In an ARP model, current y depends on several lags. These models are attractive because they are simple, interpretable, and often surprisingly effective for short-run forecasting. The coefficient in an AR1 model is usually interpreted as persistence, not causality. A large positive value means the series tends to carry momentum from one period to the next. Testing whether that coefficient is zero asks whether the past helps predict the present at all. So the emphasis is predictive usefulness, not a structural causal story. Forecasting introduces another important distinction. A fitted value is in sample because the observation being explained was already used in estimating the model. Forecasts are out of sample because we use information through time t to predict time t plus 1 or beyond. The forecast error is the actual future value minus that forecast. That is different from a residual, which is defined in sample. This distinction matters because a model can fit the past well and still forecast poorly. Forecasting is about out-of-sample performance. That is why time series work often puts so much emphasis on forecast errors rather than only on in-sample fit statistics. Lag choice is also a core practical problem. Too few lags and the model misses important dynamics. Too many lags and we waste degrees of freedom and add noise. Information criteria are useful here because they formalize the trade-off between fit and parsimony. In forecasting, a cleaner, smaller model can sometimes outperform a more complicated one. Now for the warning label, non-stationarity. Some series do not settle into a stable behavior over time. Random walks, strong trends, and structural breaks all create problems for ordinary regression logic. If the process itself changes, then historical relationships may not carry forward in the way our model assumes. Structural breaks make this even more concrete. A forecasting model estimated before a crisis, a monetary regime change, or a major policy break may perform badly afterward, because the underlying data generating process has changed. Time series econometrics always has to live with that possibility. So the big takeaway from this last time series episode is that forecasting rests on understanding persistence without over-trusting it. Autocorrelation tells us whether the past matters. Autoregressions turn that into a forecasting model. Forecast errors tell us how well the model travels out of sample. And non-stationarity reminds us that history is useful, but not always stable enough to be copied forward blindly. This closes the econometric sequence. We started with simple regression and ended with dynamic models, identification problems, and forecasting under instability. That arc is really what econometrics is about, learning how to move from raw correlations toward disciplined empirical reasoning.